Hi, we're going to do 10.2. Here I drew some pictures of some triangles. So here we have a right triangle right here. And this angle right here, the measure is 90 degrees. So that's how we know we have a right triangle, is one of the angles is 90 degrees. In a isosceles triangle, we have the same lengths on two of the sides. And the same thing goes with the angles. These angles have the same measure. All right? So an equilateral has both. They have the same length on every side and the same angle measure. Okay? For more triangles, look on page 627. All right. Well, we know the sum, when I mean me, I mean the math community. It's already been established, okay? The sum of the measures of the three angles in any triangle is 180 degrees. Okay? Well, let's look at the equilateral. I'm going to draw it again right here. This angle is 60 degrees, and this angle is 60 degrees, and this angle is 60 degrees. When we add them all up, 60 plus 60 plus 60 equals 180. Okay? 180 degrees. Now this comes in handy when we don't know what a measure is. For example, let's say we have an isosceles. Okay? These are the same. And I'm going to just make up some numbers on here. Let's say this is 70 degrees. And if that's 70 degrees, then we know this is 70 degrees. Okay? And we'll put a little x here to solve for x. Well, we have 70 plus 70 plus x equals 180 degrees. Okay? So we add the 70s, that's 140 plus x equals 180. Subtract 140 from both sides, and x equals 40 degrees. Okay, so let's do another problem. I'm going to erase this now. I sure hope you're keeping your own notes, because just taking screenshots, I know it's easy to do, but it doesn't go in your brain as well. When you go from your brain to the pencil to the paper, it sticks a lot better. Okay, so let's do another problem. I'm going to do an example. All right. Okay, we're going to call this triangle ABC. Now the measures I put inside them are not going to be obviously what they look like. So that's 59 degrees. Angle C is 59. And angle B is going to be 48 degrees. Put little degree signs here, but it just becomes a big mush, okay? So the question is, what is the measure of angle A? Well, we're going to add these up because we know it equals 180. 48 plus 59 plus the measure of angle A equals 180 degrees. Okay, we add these two, that's 107 plus the measure of angle A equals 180. Subtract 107 from both sides, and the measure of angle A is 73 degrees. Okay. Recall, vertical angles are congruent. Vertical angles are congruent. That means they have the same measure. That was our last lecture that we talked about. So these are vertical angles, 1 and 2. You can see they're congruent, and 3 and 4, they're congruent. So I'm just going to write that. Measure of angle 1 equals measure of angle 2, and measure of angle 3 equals measure of angle 4. Okay? Also, I want you to recall supplementary angles. Here we have 1 and 2. What do we know about supplementary angles? We know the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay? So we're going to do a problem now, an example, utilizing everything that we have here. I'm going to erase this so I can draw the picture. Okay, so draw a straight line, go straight down on this side, and let's see, I'll just go up this way. There, it's supposed to be a straight line. So we've got two triangles here connected. This one's a right triangle. So what do we know about that? That's right, it's 90 degrees. Okay. All right, so I'm going to make this up. Let's see, I'm going to call this angle 1, angle 2, angle 3, angle 4, angle 5. Okay. So let's see. So I'm going to say this angle down here, we're going to call it 50 degrees. All right. And this angle here, I'm going to call it 60 degrees. Now, of course, it doesn't look like it, but that's the way it goes when we're hand drawing things, okay? All right, so what we want to do is find out the degrees of all the other triangles. So where should we start? Well, here we have two. This is 90, this is 50. So we can find measure of angle 1, all right? 90 plus 50 is 140 degrees. We know the sum of these equals 180. So the measure of angle 1 must be 40 degrees because 140 plus 40 is 180. All right, that was easy. So this is 40. So if this is 40, these are vertical angles. So what do we know about angle 3? That's right, measure of angle 3 is also 40 because these are vertical angles. All right? Well, now that we know 3 and we know this is 60, we can find out this one, which is 5. So 60 plus 40, there's our 40, add 60 is 100. 100 degrees. So what does that tell us about 5? That's right. Measure of angle 5 equals 80 degrees. 100 plus 80 is 180 degrees. Okay, we have two more we haven't done yet. 2 and 4. But look at this right here. These are supplementary angles. So 3 is 40, we said. All right? So 40 degrees for angle 3 plus the measure of angle 2, we know equals 180 degrees. Okay, so we're going to solve for measure of angle 2 by subtracting 40, and we get 140. Okay, so measure of angle 2 is 140 degrees. So what does that tell us about this angle? Well, these are vertical angles, aren't they? So right away, no, because vertical angles are congruent, the measure of angle 4 also equals 140 degrees. Okay, so you'll have some homework problems that are like that. Let's go on to a different concept. Okay. We're going to look at similar triangles. Similar triangles. You know when you look at a picture in a computer and then you zoom it into it, you can make it bigger? Well, that's kind of what similar triangles are. I'm going to start off with just an example. Let's say we have a right triangle. Here's a right triangle. And we zoom into it and we make it bigger. Okay. Got to be bigger. So the ratios are the same. All right? So these are similar triangles, and that little squiggly line means they're similar triangles. Okay? So I'm going to label these A, B, C, and this is D, E, F. All right? So I'm going to say triangle ABC is similar to triangle DEF. Okay? Now something we know about similar triangles is number one. Let me put up here similar. Similar triangles. All right? Number one, corresponding angles are congruent. Corresponding angles congruent. Okay, corresponding angles. Well, A corresponds to D. B corresponds to E. So I'm going to make them congruent by putting a line there. Those have the same measure. F corresponds to C. Put two lines in there. I know it doesn't quite work with this big thing. And then I'm going to put three lines in here showing that these two are congruent, A and D. Okay, so that's what we know about similar triangles. Corresponding angles are congruent. What we also know is corresponding sides are proportional. Corresponding sides are proportional. Okay, so what are the corresponding sides here? AB corresponds to DE, and BC corresponds to EF, and AC corresponds to DF. All right, so let's do an example where this would help us to figure out something. So I'm going to make another example of some triangles. Okay, there's one. And I'm going to make one that looks just like it. I'm going to try to anyways, but smaller. Not quite. Okay, there we go. How about this? Okay, that's better. Awkward little triangles. Okay, so again, I'm going to name these A, B, and C. B, C, and D, E, F. Okay, so we know the corresponding angles are congruent. We know the corresponding sides are proportional. So let's say this is 10 inches. Side AB is 10 inches. And side DE is 5 inches. Okay, let's say AC is 4 inches, and we want to know what DF is. Okay, I can put an X there, or I can put a little e there. Sometimes in geometry, they'll use a little e to signify opposite this big E, but you don't need to know that. We're just going to solve for the letter E. Okay, so we're going to look at the ratio of the large triangle to the small triangle. Okay, proportion is when ratios are congruent. Okay. All right. So the large triangle here is 10 inches, and the corresponding side is 5 inches. All right. The large triangle AC is 4 inches, and this corresponding side, we don't know what it is. We're going to call it E. And now we're going to solve for E. Well, remember, we can cross multiply. 10 times E equals 5 times 4. 10E equals 20. E equals 2 inches. Okay. So let's look at a more complicated problem using similar triangles. It's not really more complicated, it just looks more complicated, but we'll break it down so it's not so difficult. Okay, so let's say we have a triangle And then we have another triangle within the triangle. See the smaller triangle and a large triangle? Okay, this is 90 degrees and this is 90 degrees. Okay, so what we're given is this length right here is 5 meters. And this length right here is 4 meters. And we're given this length right here, and I'm going to call this, let's see, I'm going to call the small triangle E, C, and D, that small triangle. And I'm going to call the large triangle A, B, and C. A, B, C is a large triangle, and then the small one is D, E, C, small triangle. Okay, so our question is, oops, can't get to the question yet. This is 5 meters from E to C. The question is, what is BE? What is X? Okay. What we're also told is triangle ABC. Well, we can actually see it. Triangle ABC is congruent to DEC. Not congruent, similar, sorry. My cat is walking by me. Go on. Okay, so what do we know? We know 5 and 4, those are corresponding sides, right? So we'll look at the large triangle to the small triangle again. But if it's hard to discern, we can split this up. We can say, well, here's our large triangle, and here's our small triangle. Okay, so we know this is 4, this is 5. And we know this is 5. But what do we know about this? Well, if this is 5 and this is x, all of this is x plus 5. Now that's going to help a lot. Okay, so large triangle we have 5. Small triangle we have 4. Large triangle we have x plus 5. Small triangle we have 5. Now we're going to cross multiply. 5 times 5 is 25. So we went this way, and now we're going to go this way. Now remember, when we're doing this, we have to put our parentheses. And if it helps, you can put the parentheses up here so you remember, because we're going to have to distribute that 4. So we have 25 equals 4x plus 20. Subtract 20 from both sides. Okay, divide by 4. X equals 5/4 meters. And what does that equal? 4 goes into there 1 time, and 1 left over. So 1 1/4 meters. Okay, so we're going to go to a different concept now, and I'm sure you've seen it before. The Pythagorean theorem. And this will be our last concept for this situation. Pythagorean theorem. The Pythagorean theorem, I'm sure you've seen this before. If we have a right triangle, it has to be a right triangle. And we're going to call this side A, this side B, and this side C. The Pythagorean theorem states that if we square this length and square this length, we call those the legs, it equals the hypotenuse squared. Okay, a squared plus b squared equals c squared. So I know you've heard that. So in reality, what we're doing is we're squaring the legs of the right triangle, and it equals the hypotenuse squared. Hypotenuse squared. Okay, so let's do an example of this. Here's a right triangle. It's kind of hard to write when I'm laying on the floor here. Okay, so this is 3, 4, and x. Using the Pythagorean theorem, we know 3 squared plus 4 squared equals x squared. 9 plus 16 equals x squared. 25 equals x squared. I just switched it the other way. Now we're going to square root both sides. And remember, when we square root, we plus and minus. So x equals plus minus 5, but we don't have negative length, right? We can't have a negative length. So we just look at the positive one. So x equals 5. Okay, so let's apply this to another problem. We're going to use the Pythagorean theorem, and this will be our last example for today. Okay. All right, so this is 5 feet. This is 13 feet. And we want to know this length. We're going to call this length A. Using the Pythagorean theorem, we can square the legs. So we have a squared plus 5 squared equals 13 squared. All right. A squared plus 25 equals 169. We subtract 25 from both sides, and we get 144. Square root both sides, just looking at the positive number. Square root of 144 is 12. So A is 12 feet. Okay, so here's your homework, 10.2 homework. 1, 3, 5, 11, 13, 14, 15, 21, 23, 25, example 4, and then 37. All right, if you have any questions, please make sure to ask.